You graphed tangents last year, probably out of just, it's come up on an Algebra 2 Regents here and there, but not a lot at all. So when you see this, it will look familiar, but I know you didn't do a lot of work with it. So, Brian, can you get out your note packet? Rock, that would be a nice idea for you too. Okay. The thing about tangents, and let's look at the unit circle. What is the tangent of 0? Tangent of 0, if you had your chart in front of you.
0.
Tangent of 0 is 0. And then as you work up through your table, the tangent of pi over 2 is what? Nope. Undefined. So the tangent values go from 0 to root 3 over 3 to 1 to root 3 to undefined. So they sort of increase indefinitely until it's undefined. You're not thinking of your 0, 30, 45, 60, 90. Your tangent values are 0, root 3 over 3, 1, root 3, and undefined. So on a unit circle, just going through the first quadrant, that sort of takes us through that. Then in the second quadrant, it works its way back down to 0. And tangent is positive in the first quadrant. In the second quadrant, it is negative. And then it works its way up again indefinitely to undefined. All students take calculus, so it's positive there, and it's negative in that quadrant. So what's unique about this graph is that we have undefined values. And if you're looking at a graph, and I'll do this from, I'm going to center it actually. I'll go from we'll start at 0. I'll make this, every 4 units will be pi. So that'll be 2 pi. So that this will kind of correlate with my unit circle. So we said the tangent of 0 was 0. And it works up to at pi over 2, it's undefined. And that undefined value on a graph makes an asymptote. The graph will never actually cross pi over 2's vertical line because the function's undefined there. As it moves from 0 to that undefined, these values are slowly increasing to infinity. And that mimics the behavior that every graph has as it approaches a vertical asymptote. Whenever you approach a vertical asymptote, you shoot up towards infinity or negative infinity. So if there's an asymptote at pi over 2, we also have an asymptote at 3 pi over 2, which is halfway between pi and 2 pi. So put a vertical asymptote there. And at pi, from our unit circle, the tangent value is 0. And it increases towards the asymptote in that direction and decreases towards the asymptote coming from the other direction. And then lastly, in quadrant 4, which is just on the right side of this asymptote, the tangents are negative, so they come from negative infinity until you get back to 2 pi, which is where the tangent is 0. So that's just 0 to 2 pi, and then if I were to transition this backwards to negative 2 pi, you'd have an asymptote at negative pi over 2. And it would just go down like that. Because these are negative angles. So if you're looking at your unit circle and you go back negative angles into your fourth quadrant, your tangents are negative again. That's why those are going towards negative infinity. and then you'd have another asymptote at negative 3 pi over 2, and that pattern just continues. Do you remember this? You didn't do much with it, but this is what this graph looks like. It's not a continuous wave like sines and cosines. The biggest key values are right here. Knowing that at all of your pi's over 2, that's where it's undefined, and that's where you have asymptotes. Now, those can shift left and right when we shift these graphs. Those can stretch and compress and spread out or shrink together. So the location of those asymptotes can change if we have any horizontal movement to the graph. Yeah. Negative 2 pi is going to be a 0, and on that side it is going to go like that. Sorry, I just kind of stopped the pattern. Because this is a little bit funny. Like if you look from 0 to 2 pi, you've got one full cycle, and then your other cycles kind of split up. So it's probably really best to look at it and think of it between negative pi over 2 and positive pi over 2, because you actually get that full structure that just keeps repeating. Like if I went beyond 2 pi, that would go up, and if I went beyond negative 2 pi. So it's really this same shape that just keeps going over and over again. So at your zeros and your pi's, that's all where you have zeros. Okay? Talking about amplitude, which is the height of a wave, doesn't make any sense with tangent graphs. We can still have vertical stretches. I could still put a 3 out in front of this, and it could be y equals 3 tangent of x, but that is not referred to as the amplitude. So you would say really does not exist, because amplitude means the height of the wave. You might more be asked, what's the vertical stretch, which is the same thing essentially. Your frequency is the same thing. It's still the number of cycles you get between 0 and 2 pi. So if that's 0 and that's 2 pi, how many cycles fit in there? 2. Again, it starts at a weird spot, but there's starting at 0 going up, and then coming up to 0, that's 1 cycle. Starting at 0 and going up, and then starting down here and coming up to 0, that's a 2nd cycle. So the frequency is actually 2. What is the length of one of these cycles? Just pi, which is also different, because sines and cosines have periods of 2 pi. Tangents have periods of pi. So for sines and cosines, we use the formula period equals 2 pi over b. For tangents, it's just pi over b. So your period, your standard period is pi, and then that might stretch or compress based on your b value. Does that make sense? Different formula. Period equals 2 pi over b for sines and cosines, which is pi over b for tangents. And function with a question. Nope. This b value. So this is your that's your thing. So this is technically y equals a tangent of b x minus c plus d. Your b is 1. So our period for the parent graph anyway is still pi over 1, is still pi. It takes from 0 to pi before this is going to repeat itself, right? Because frequency is the number of cycles you get in from 0 to 2 pi. And I've gotten in, here's your first cycle that I get in by pi.
So we should put that in.
Okay. I never talk about frequency for this reason. Frequency is not always b, no. It is for sines and cosines. So that whole idea is very exclusive to that. And if you had me for Algebra 2 last year, I almost never talk about frequency because it is hard to pull it just from an equation because it differs for sine and cosine as it does for sine. with that switch, though, at the same time, I talk about period more often, and I do make it a point because the period formula changes. Sine and cosine, it's 2 pi over b. Tangent, it's just pi over b. So, again, pulling frequency from an equation, I'm not a huge fan of. And a tangent one, definitely not. It's not even correct. It's not b. Good. I'm glad you said that. Yeah. Function, is this a function? I'm going to guess that's what she means by that. Yes, because it still passes the vertical line test. So yes, it's still a function. And I don't really know why that is there, so I'm not going to talk about it. Okay. Let me just take a look at your homework tonight quickly. Okay. So with tangent graphs, and we haven't done this yet for sine and cosine, we're talking about the tangent graph today, and that's really just the parent graph of it. And then we're also going to talk about the reciprocal function, which we haven't done with sine and cosine yet. We haven't done cosecants and secants. We'll do that tomorrow. But we'll do all the tangent ones. We'll do the reciprocal function, and we'll also do the inverse function. So for the tan function, I'm just going to replace the values in there. So 0, pi, and 2 pi have tangent values of 0, and these are undefined. So the reciprocal function is just reciprocating those values. What's the reciprocal of 0? Undefined. So all of your zeros become undefines, and all of your undefines become 0. So it kind of flip-flops. In the tangent graph, your asymptotes are all at the pi's over 2. In your reciprocal function, all of your zeros become your asymptotes, and all of your asymptotes become zeros. So one way that you'll see that I like to iron stuff out, especially if we start graphing things with transformations, on a tangent graph, your asymptotes are at k pi over 2 to start. Whether it's 1 pi over 2, where k is odd. I should say k is odd. Your asymptotes are at 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. And on the reciprocal graph, all your asymptotes are at k pi over 2, where k is even. So 2 pi over 2, 4 pi over 2. Essentially, your asymptotes and your zeros just flip-flop. So when I set up my cotangent parent graph, rather than having asymptotes at negative pi over 2, pi over 2, my asymptotes are going to be at 0, pi, 2 pi, all the whole number pi's. And you see how your tangent graph is always increasing? Cotangent graphs are always decreasing. So they start and go up top and go down and squeeze in between the asymptotes. So I don't know which way is better for you, but I just added, for if you're memorizing where the asymptotes are of the regular tangent graph, they're at your reference angles of pi over 2. And on your cotangent graph, they're at all your whole pi numbers. 2 pi, 3 pi, 4 pi. Yeah. K is just a constant. This is really the official way that math would write it in like a textbook. K pi, any K pi over 2 where K is odd, so that'll be 1 pi over 2, 3 pi over 2, 5 pi over 2. Hence, things with reference angles of pi over 2. And if K is even, 2 pi over 2, 4 pi over 2, those will all reduce to whole pi's. Right. Exactly. This is just an easier way, the way I second wrote it, that's an easier way to interpret it and memorize it than the notation you would see in a textbook. Okay? So those two are very closely related. The last one here, which I don't even think you know what arctan means, do you? Anybody? That's the same as the inverse. For whatever reason in trig, they have another notation. It still means the same thing as inverse tangent. So the main feature of any inverse function is what? To go from the original function to an inverse function, what do? Flip the x's and y's. That's an inverse feature of all graphs, whether they're trig or not. So where our x's and y's used to be, and let's go back up to our tangent, 0, 0, we're going to flip 0, 0, which that one at least will still be 0, 0. We're going to flip pi over 2, comma, undefined, and it's going to be undefined, comma, pi over 2. For pi 0, you're going to flip it. It's going to be 0 pi. For 3 pi over 2 undefined, you're going to do undefined 3 pi over 2, and then lastly 0, 2 pi. Inverse is just flip the x's and the y's. We will do the inverse functions of sine and cosine as well. We will do the reciprocal functions of sine and cosine as well, kind of split up into 2 separate days, tomorrow and Monday. But we kind of address these concepts of reciprocating and flipping here. I think this is going to create something somewhat, I know what the graph looks like, but I'm going to try to explore it with you from like a pretending like we know nothing. I think we're going to have to explore this a little further, because what gets immediately confusing about this is how do you plot 0, or well, really undefined on your x-axis, right? That doesn't really make much sense. We can definitely scale our y-axis from 0 up to 2 pi. So I'm going to call that pi, and I'm going to call that 2 pi. And I'm almost going to flip the way I graph this. At a y coordinate of 0, I have an x coordinate of 0. But at a y coordinate of pi over 2, x is undefined. So you actually get asymptotes that have now been flipped. If your y coordinate is pi over 2, there is no point there. At a y coordinate of pi, you'd have an x coordinate of 0 again. So there's another point. And then again at 3 pi over 2, it's undefined, so that puts a horizontal asymptote there. I have a point at 0, 0 and a point at 0 pi. And I'm going to have another point at 0, 2 pi. This is why we're going to need more exploring, because we're not seeing what happens elsewhere. like we only have 1, 2, 3, 4, 5 y values, and it just keeps bouncing back and forth between 0 and undefined, 0 and undefined. Other things are happening, but before we get there, what could you say about this graph just based on the way these 3 points are oriented? This graph is not a function because it's failing the vertical line test. We never have points on top of itself, so it's definitely a weird thing. Do you remember how with inverse tangent, what was the range of inverse tangent? Negative pi over 2 and positive pi over 2. And I'm going to show you for the first time why that was. So if the range is negative pi over 2 to positive pi over 2, the reason for that is because that section of the original graph from negative pi over 2 to positive pi over 2, does that pass the horizontal line test? Right. So if that little section passes the horizontal line test, then when we invert just that section, it will then pass the vertical line test and be a function. Which is, if we did the horizontal line test with everything, the inverse of this would not be a function. And that's what we're seeing right here. This is the inverse. It's not going to be a function. But if we just looked at the section between negative pi over 2 and positive pi over 2, because that section passes the horizontal line test, its inverse will pass the vertical, and its inverse will be a function. So I'm going to create another table of values just looking more exactly at the tangent function just between negative pi over 2 and positive pi over 2. And I'm not going to do all the values. I'm just going to do the easy ones. So at negative pi over 2, the tangent is undefined. At negative pi over 4, what's the tangent? Tangent of pi over 4. I picked that one because it's a nice number. Tangent of pi over 4. 1. And we're in the fourth quadrant, so that's going to be negative 1. Then 0. Tangent of 0 is 0. Then positive pi over 4 has a tangent of 1. And positive pi over 2 has a tangent of undefined. So I'm just looking at the tangent graph between negative pi over 2 and positive pi over 2 because it passes the horizontal line test. Which means now when I flip all those points for the inverse tan graph, and I'm literally just going to flip them all, those 5 points will pass the vertical line test, will be a function. So I have an asymptote at a y of negative pi over 2 and positive pi over 2. I already had the positive pi over 2 one. The negative pi over 2 one will be right here. I have a point at 0, 0, which I already had on the graph. And I have a point at 1. Where should I make 1? I'll do it here. 1 pi over 4. And negative 1, negative pi over 4. That's pi over 2. That's pi over 4. So what you'll get there, and it's really just kind of a reflected version of the tangent graph, is just a sideways tangent graph. So that stuff we did initially was really just for the purpose of showing you that this is not, in its entirety, it's not going to be a function. But we limit it to negative pi over 2 to pi over 2 so that this section of it does pass the vertical line test. Agreed? And that is the reason why when we did inverse tangents, we limited it from negative pi over 2 to pi over 2. Because that's the only section that passed that line test. Do you follow? Just quickly, because we're done with that. Do you remember what the range of inverse sine was? It was also negative pi over 2 to positive pi over 2. The reason, if you look at your sine parent graph, this little section from negative pi over 2 to positive pi over 2, right in here, is a small section that actually passes the horizontal line test. So that when you do its inverse, it will pass the vertical line test. That's why that was what it was. Do you remember what it was for inverse cosine? 0 to pi. And the reason for that is because on a cosine parent graph, 0 to pi, which is this little section in here, that's the section that passes the horizontal line test. Which I didn't show you at the time, and I didn't really plan on it, but I guess it comes up anyway. So, again, hopefully by now you've memorized what those inverse tangent, sine, and cosine ranges are. But just to give you some context, that's why it is the way it is, because you can't invert things that don't pass the horizontal line test if you want them to still be a function. Okie doke. We'll probably talk more about that tomorrow when we do inverse sines and cosines. Okay. There's 8 questions, but only 3 of them are graphing, so you're going to do the whole thing. Some of them are as easy as what's the period of tangent, which is pi. What's FCP?